Let me tell you the problem. So we have the AWS ECS cluster. So we're running it with EC2 type. And why? Because this deployment is really highly loaded. So this is the ECS cluster with EC2 instances. And we're using EC2 instances as capacity providers instead of Fargate. Because first of all, this deployment is highly loaded. So it means that we will have lots of services, big traffic. Second of all, we will need as much customization capabilities as possible, and Fargate limits us to creating persistent value storages. So it only allows to create inferior storage, that is life cycle of which within the container life cycle, and we need to be able to create the persistent volume. And we also want to have radical cost optimization. And with ECS, when using EC2 instances, you can benefit from Spot because ECS takes care about instances provisioning. So when Spot cancels your instance, ECS will provision automatically. There are a couple of things why we're using that. I'll be discussing in another video. And now we have the following problem. So we have one service, let's call it ingester. This service is running in EC2 instance. It has two replicas, red and blue. Let's say we have in another instance, we have Nets, and Nets is our a queue broker, event streaming, whatever. So we deployed them, and the only limitation is that this ingester works with some specific type of the client, and this client is, let's call it old school client, so it uses UDP streams. So we have our network load balancer. So LLB network load balancer. Why network? Because we need to forward UDP streams. Application load balancer works on the TCP level, high level, so it cannot deal with UDP. Network load balancer can deal with UDP. Everything hosted here, located within the private virtual cloud. So yes, we can't access these instances, whatever. Nothing accessible from internet is in the private cloud. The network load balancer creates public endpoints that are accessible from the internet and allow and forwards traffic to the ingesters. So we have our client. We don't have access to this third-party client, and we can do nothing about it. It's a legacy client, so they're using UDP. And this is really painful for us because we need to manage that traffic. So they're using UDP, and they're sending UDP packets via open UDP stream to our ingesters via, let me do it like this. Yep, that will be nice. To our ingester, they're sending UDP packets. So there are a couple of instances here. So these guys, ingesters and nets, they are deployed as ECS services. So it means they're running on the ECS, these are tasks, they're running containers inside. Now, when you're running Fargate, when you're running the container, you need to specify the network mode. So there is something called network mode. So there are multiple network modes, and by default, the most flexible one is AWS VPC. It's just literally like this. So what is network mode? Network mode responsible for basically setting up how the containers, tasks, whatever, map into the virtual private cloud network, right? So for instance, with network mode AWS VPC, each container receives the IP address, internal IP address within virtual private cloud. So you can basically port that this container is deployed on. So you can type the IP address 10.0.0.1.20, whatever, and the port 5000. This is basically how you access the container. And when we were deploying the ECS on the Fargate capacity provider, this is the mode we're using because this is really flexible mode. We can set up security groups here, so we can set up who can access this container, who cannot, whatever. But when we're running in the EC2 instance capacity provider, there is one limitation. So there is something called ENI, like Elastic Network Interface. So this is basically the interface AWS provides to every container to assign it with the IP address. And the limitation that most of EC2 instances only capable of having 2 to 5 DNIs, depending on the instance type. So large instances with more compute, more expensive, one can have 5, maybe 7. The cheaper instances, like up to large, can have 2 to 3, and this is really limiting. And why? Because when running the containerized deployment, that's the benefit for us, that we can gradually allocate the number of resources for each service needed. So for instance, this ingester needs 2 CPU and one CPU and 2 gigs of RAM. This one as well. This needs maybe a bit more. So that's why we allocate the number of resources needed for each of these services, and we can fit in within instance as many containers as we want until the instance has the capacity to load them, right? So in these EC2 instances, we can have dozens, 10 containers of different services, and we are not limited. So that's the benefit of containerized deployment. But with having AWS VPC network mode, we can't do it because AWS needs to assign the IP address to the EC2 instance. And it's not the EC2 instance IP address. EC2 instance has different IP address. It's the address of the container within EC2 instance. And the problem is that AWS can only assign a couple, as I mentioned, 2 to 3 addresses like this. So it means we're limited to containers per instance. And it's really excruciating because provisioning new instances, it's not an easy task and it takes a couple of minutes. And we want to avoid, we want to be cost effective, we want to fit in as many services as we can into our minimum number of instances. So that's why AWS VPC network mode is irrelevant for this deployment. For Fargate, it works really well because Fargate, we do not use EC2 instances. We do serverless. For this type of stuff, it's irrelevant. So there are another modes called host and called bridge. So what host does, host simply, when your container runs on port 5000, so it will automatically bind the 5000 port to the host machine, right? So your EC2 instance has an IP address. Let's say this is address of EC2 instance, and you're running container on port 5000. So the address of your container will be address of EC2 instance plus port. Then you have another, let's say, another instance running in the same container. So this instance can't have, the container running in the instance. This container can't have the same IP address because they will conflict. So we need to give him another port, and this is how you access this one. So basically the port of the container is mapped to the port of the host machine. And the bridge mode is similar to the host mode, but it allows you to actually manually assign. So for instance, if both of your containers running on port 5000 and you don't have control, you don't want to go to the application code and change the port, what you can do with bridge mode, you can simply say the container running is on 5000, but 5000 is actually occupied by another service. So what I can do, I can create 5002 and map it to the 5000 of container. So it means that, let's say this is our 5002, it will be mapped up to the 5000 of the container. So this is a bridge mode, right? So bridge mode allows you to map. So when you're deploying to ECS without Fargate, with EC2 capacity provider, you must consider one of these. And I will consider bridge just because I have more control over which port I can assign to the specific task versus just relying on what it is in container. But there is another challenge. So the first challenge is that our services running here, they can have security groups. So it means that if we allow someone access our EC2 instance, they have access to all the services. So the only way how we can restrict them is in the EC2 instance security group. So security group now not on the containers, but on an EC2 instance security group, we can specify who has access to which port and thus map with the ports. So now you need to manage this one. And also you must have unique port, as I mentioned, per each container, because if they intersect, they will conflict and they will never be deployed. So with AWS VPC, it was really flexible because you have the same port for every application. You don't care because application receives the static IP address. but for the host, you can't have it because you need to have the unique port. So if you don't want to define the unique port for each application, the breach mode supports dynamic port mapping. So what does it mean? It means that, let's say your application running on port 5000 and you do not handling yourself which host port will represent. So the port 5000 is port of application. And now you need to bind it. We need to bind the 5000 to the host port. So let's say this guy has 5000 and it is mapped to the 5000 of the EC2 instance. So it means this one couldn't be mapped to the 5000. And you can't, and you don't want to do it manually. You don't want to figure out the port manually. So what you can do, you can say, please assign it to any port you want. So what AWS does, it uses something called ephemeral ports. So basically ephemeral ports, and they are in the range of these from 32,768 and 16,000 to 99. These are the temporarily ports. So these are ports that temporarily assigned. So in the breach mode, if you use dynamic mapping, so you will have similar like this, but they will just, AWS will choose which port. So they'll assign to some random port. And that's really convenient because now you have something similar to AWS VPC. You don't need to care about the host machine port because AWS has figured out. You have application running with unique port every time. However, there is one problem. So let's say you want to create the internal DNS for your container. So everything happens within virtual private cloud. Let's create this thing and call it VPC. So this is our virtual private cloud. So now we create something called service discovery. So what it basically does, it assigns the domain name to your container. So now you're not accessing container by the IP address, but you have domain name. So let's call it something like Ingestor Red Services Local. So this is a DNS name, like the website name, but this is internal within virtual private cloud. So outside this address won't work. It only works internally. So it means that any service of these can access this service, but this domain address. So if you configure this service to communicate to this one, you will have the address. In my use case, the thing that has DNS is nets. So we basically have something like nets services local. So nets running on the port 4222, this is default port, and it is mapped to some random ports on the instance level. Let's just type different one because it will be different. And now Ingestor wants to access this one actually the same. Just copy it over so it won't confuse you why everyone has the ports and mappings and this one doesn't have. So they have 4 mappings and this Ingestor wants access nets. So it literally wants to access nets, right? But it needs to use the address. So it uses that's good. But now there is a problem. It also needs to know the port. And if you type, this thing won't work. Why? Because the 4222 is an internal container port, but not the host port. Means that this URL will not work. So which one will work is this one. But there is a problem. When you configure your deployment, you don't know this port because this port is dynamically assigned on the runtime. You only know this port. So it means that you can't specify this port because you usually specify it via environment variables, and you can't. Because even if you dynamically extract this port and supply it here, during deployment process, it may change frequently. It means that the connection between Ingestor Blue and nets will be broken. So to solve this issue, Amazon offers us something called SRV DNS record. That's where the SRV DNS record is. So let's imagine a DNS record. Everyone knows a DNS record. A DNS record is simply we're mapping the domain name to the IP address. Yeah, so literally, let me do it like this. So we're mapping domain name, it's straightforward. And now when you access this domain name, you map to the IP address. So Service Discovery actually adds this record to the Road 53 internal. Service Discovery creates internal Road 53 zone and adds this record. So when you run this, it maps to the IP address. But it still does not resolve port. You need to specify port manually. So SRV basically helps you to sort out the port. So how this record will look like this. First, it has the port number, and then it has the IP address. Sounds really great, isn't it? But there is one caveat. Most of the libraries use default HTTP client, and by default, when HTTP client accesses domain name, the DNS resolution system in HTTP client does not work with SRV records. So it means that it simply will not resolve these NAT services locally, will not be resolved because it won't find an error. It looks for A records. So in order to obtain the dynamic IP address, you need to create a code with the custom DNS resolution. So basically, you need to create a code that look up the SRV record for this domain name, extracts the port and IP address, and then it creates a request to the port and IP address. That's the solution for this problem. However, it's a big bottleneck because let's consider my use case. I am the cloud engineer. I'm creating the cloud infrastructure for the developers or application engineers. They don't have much understanding and knowledge about networking and how it works. So it means for me to ask them to create this resolution will be a huge bottleneck. And it will mean that if you forgot to do it, your system will crash. So it's really dangerous. And I prefer to avoid it. So to avoid it, we have two approaches. AWS VPC network mode, which is, as we discussed, will only allow us to run 2 to 3 containers per instance. And it's not an option for us because it will be in our head. We'll pay lots for compute resource that is unused, and we will be less scalable. So we want to avoid this. Then if we use the host to bridge mode, the host mode will bind our ports to the same port in the host machine, and the bridge mode will bind to whatever ports we prefer. But we will not be using dynamic port. We will be using the static one. And the static is explicitly specifying which port. So it creates a bit of overhead on the infrastructure setup because now you need to have a centralized config file that sets up the port number for every network interface. So if, let's say you have Gesto, it has 5,000 port, but it also has for TCP, but it also has the 9,000 port for UDP. So these are 2 separate network interfaces. Even they're running from one process, from one service, from one application, they need to be separately mapped to the host machine. And each of these ports on the host machine must be unique across all the cluster. And why? Because technically we can keep it unique just within one instance. But with S-cluster deployment, we don't know and we don't care to which of the instances our containers are deployed. Well, technically we can care. We can set up relation between instance and container for some cases. But if we don't have a need to do it, we better avoid it because it just creates more complexity and reduces our scalability. So it will be much easier to have the host port to be unique across all the cluster, so you will never have the port conflicts. So that's the idea of how we're deploying TS cluster containers with the EC2 instance capacity provider. So now let's jump to the source code and set up this system for centralized unique port configuration. And I don't like ClickOps. I'm trying to never open AWS console where I actually open it, but I only open it for mostly reading, monitoring. Sometimes it requires to do some manual actions when you playing and messing up with your Terraform and you need to resolve some conflicts. But in most cases, I do infrastructure as a code first, aka Terraform. So this is my Terraform. This is the root file. So it's pretty straightforward. It has the module with cluster setup that setups all the cluster and EC2 instance capacity providers. And I'll create another video on how to deploy ECS cluster with EC2 capacity providers and how to properly configure to scale into it. So stay tuned. This is the NATs. This is simply ECS service that deploys NATs. And this is the custom module that contains these UDP configuration. So basically this module has the configuration to network load balancer, same we had in diagram here. It has the target loop and listeners for 2 replicas. It has some S3 bucket setup with policies, and yes, and it has the service setup itself. So it creates security group, the gmax ingester, and it created in 2 replicas. So I define the local variable with replicas names, and then I iterate and create 2 similar replicas, just because we want to run 2 separate failover replicas simultaneously. So it's pretty straightforward. Right now it uses AWS VPC mode, and we'd agreed that this mode will not work for us. So let's go to the ECS service module that actually creates all the resources for ECS service. And this service has a couple of locals. I'll explain them. So sort of policy, roles, policies, more policies. I'll create another video about the ECS service module. Yes, and how to properly deploy to ECS, so stay tuned. CloudWatch group for the logs gathering, then the task definition that defines all the container settings. Discovery service, the one that assigns a DNS name, and the ECS service itself with lots of dynamic configuration and auto-scaling groups that could be enabled or disabled depending on the use case. So what I want to do particularly here, I want to completely disable the AWS VPC. So we will not use AWS VPC just because it's limited, but we'll also need to provide the host and container port. So technically in our use case, we can consider host versus breach. So the difference between host and breach is that if we use the static port in breach, that will in most cases be the same as the port of container. So we can configure, we can have environment variable that provides the port to the container, and then we're setting up the port to be the same. Then it's an ideal scenario for us, and then this is pretty much the same as a host, but it's not exactly the same. Why? Because in the host mode, the network of the container itself is integrated into the network of EC2 instance. So in breach mode, containers have separate network within Docker, and we're still doing the port mapping, even if the mapping to the same ports, but just because we have different networks. So the breach mode has 2 networks. One is the EC2 instance network, and one is the container network, and they get mapped. So even if you're mapping to the same port, there are still different networks. So technically, we have slightly performance bottleneck because it's just another network redirect. But considering that everything is running within the same physical location, the same virtual private cloud, so I think we might be losing a couple of milliseconds here. So it's really irrelevant for, I don't know any use case in the world that will be really tolerant to a couple of milliseconds delay. But with the breach mode, we have more flexibility, because if we have some service that has static port that could not be configured, then we can redirect it to the different ports, so we can have flexibility here. Also, if we have the service, let's say that just we don't care which port it runs to because it's only AWS access it internally, so we configure it to dynamic ephemeral port. So I would prefer to stick with breach, even if this tiny performance and network overhead that we'll probably not notice anyways, because most of the containerized system in the world run in this multiple network, right? The VPC has one network layer, then EC2 instance at another network layer, then container has another network layer. So when the client accesses your system, it goes through 3 network layers redirected, and he might lose 1-2 milliseconds on that, but we don't care considering the benefits we're getting from it. So I would stick to using breach mode still. So in our code, we should eliminate the VPC network mode at all. So what I'm gonna do, first of all, I'm gonna go and delete the variable. So I don't want the network mode to be the variable anymore. Now I have the variable with this, I'm just deleting it, and we will not have. So this is how we configure the address of our service. So if we created service discovery, it will have address. And in previous case, when with VPC, we were assigning our traffic port. Otherwise, we'll be leaving it empty, assuming that SRV will be resolved. But now we will not do this. So we will just delete this. And then here we just will have traffic. No, it's going to be not local, but variable traffic port. Straightforward. So let's go further. Network mode. We will always use breach, no discussion. Now, port mappings. So ideally, we should always use the same ports, so they're gonna be static. There might be the case when the container port is different from static. So we might eventually, if we face this case, we will create two variables. But for now, I don't have such use case, so I'll keep it as one variable. And yes, and we also have additional ports. So it's a variable of the object that has port protocol. And we're using it, for instance, if we want to have one port for the traffic, another one for monitoring. There are some services that are doing that. So we expose it like that. And in this case, we will still use the same port. And again, if we will need to map it, we will need to, because if we're talking about NAT service, I doubt they allow us to configure the port. Let me check, basically. Yes, we can configure now. So I just checked we can configure the another variable. So I would prefer to have the same port on both containers and host. Why? Because it will be easier for us to troubleshoot. So for instance, if we are in container, we know it's running on port 5002, we know, okay, this is the same for on host, so we don't need to go to the mappings and figure out which port is mapped to. It just simplifies life for you. So I prefer we have everything consistent, and at this moment I'm restricting this module to configure static ports the same, and to avoid the conflicts, the unique ports we'll configure on the higher level. We'll do it soon. This one is good. So now we don't need this one. So now we don't need the SOE records at all. So what we're gonna do, and we don't need condition here. So we just make DNS records, and we'll always have a record only. So no discussion, no SRV, anything like that, just a record, and it's no longer dynamic. That's it. So now AWS ECS service. So we don't need this one because we won't have AWS VPC, never ever. Yes, and we're good here. Now we're strictly on the, let's check how couple on use environment, we couple use variables in this module, so we just delete them. Great. And I think VPC subnets is also probably something that unused, because we just told that we'll be running breach mode all the time. So now we adjust the module, and what we need to do now, so on the high level, we need to create a centralized config. Let's go to ports, just simple, right? So now I can specify each of the services and which port they have. So for instance, we have NATs. Let's have an object, and we have client port equals. Then we have HTTP port. Now we have the cluster port. So cluster. So the idea why we need 3 ports per NAT, first of all, because right now we have one instance of NATs, but when we scale up, we will have a NATs cluster. So we have multiple instances of NATs running, and each of those must have a unique port that do not intersect with each other. So yes, that's why we need to keep them separate. Then let's have, I think the port suffix is redundant because we know that these are the ports. So traffic will be 9000, then morning health 5000, and now we can have blue 9001. So why we keep these centralized? Because we will be adding more and more services here. There will be a whole bunch of them, and one day in one place we can see some pretty new service and see, I want to assign some port to you. Is it free or it's allocated so far? And that's when someone reviews the code, you can just check if there are any ports that intersect with each other. So just comment that must be unique. That's pretty much what we have. We have 3 services at the moment. We haven't centralized globally, set up globally, sorry. So let's go now to our main file. What I have just learned from NAS documentation is that the NATS doc image does not reading environment variables for the port. So it stores the environment variables in config file, and it requires some gimmicky workarounds. So what we'll do, we'll need to extend our service to accept both container. So we'll have this optional. We have traffic container port, this optional. So it will be only for the services like that doesn't allow us to configure the port via environment variables, whatever. So we need to specify it explicitly. And here I'll use the container port also. So what we're gonna do, we'll go to the task definition. Here we'll do the following: host port, var traffic, no. Cool. So we just did dynamic one. So if traffic on port is not 0, so it's on default, we have a custom we specified. Otherwise we specify the host port they match. Now here's as well. So we say port container port does not equal 0, then port container port, otherwise port. Yep. So we have them dynamic. And what we will do right now in our current setup, so we will not need these environment variables anymore, but we'll have traffic container port to equal 4222, and then this one will be local ports net client. That's it. We also can configure this one, but it's not relevant for us right now. We're only exporting the client port, so that's totally fine. And we have this one is different. That's totally fine. Now this module, let's simply go to this module. Just create another variable that called ports that will have type object. The object will have another object will have traffic number and health number, and then just let's duplicate the same one and blue. So we have this variable. Now what we can do in here in main, we just say ports equal local ports. That's it. So we just transfer local ports, but we only care about not every port, but just of these two servers they use. Now here, let's create another file called locals, because these locals are used among multiple files and I don't want them to be here. So these guys will not be strings anymore. We'll make them objects. Name equals red, ports equal var ports red. That's it. Straightforward. Just duplicate it, add comma here. Now ports blue. That's it. Straightforward. Now we need to find each instance that uses this local to fix, because it got used to the string, but it's not string anymore. So let's go to the load balancer first. So we're using it here. So for instance, this one no longer works, so we need to type name here as well. Name, it will see name here as well. Name. It's pretty much. By the way, we don't need these smart anymore. They are deprecated. Great. So now let's go to the services and also search for this guy. So that's good. Name ports. Let's go to the port. So traffic port will be the same thing, but instead of name, we will use ports traffic, and then why it doesn't like traffic? I don't know. We'll figure that out. And then here we use ports health. That's it. Let's search for another instances. So this one is length, this one has name, this one also has name, this one has port. We good here. So it doesn't like it. We don't need this one anymore. Just a couple of changes. And then if we go to variables, I'm pretty sure there are some duplicate unused ones. Yes, this one is no longer relevant. Public subnets, this one is okay. We have deleted some. Let me check, because security groups, the security group is also no longer relevant. So that's another story, because we want to allow so we can set up the security group for network gateway. Neither we can set up it for the breach container. So it means that in order to allow someone access container, we need to allow the external traffic to UDP. And we specify the external IP addresses below it too. But now this should be moved to the EC2 instance level. So we will delete and do it at the moment. Great. So we have this here. This one is good. Just another thing I just recalled. So if you go to the load balancer, we also have some ports here. So this one should be also changed to use the proper port. So we're using ports traffic. Yes. And here we'll use ports health. We all like it. Listeners. I don't care about listener ports, because these are the ports of network gateway, network load balancer, sorry, not the ECS ports. So we can use whatever the shit we want to use here. Well, technically we can make them match the internal port, just so we stay consistent. I like to say, well, technically it's a bottleneck because it's exposed the internal port to the outer world, but I don't think it is much of the cool. So as far as the port is unique, we can also have it here. So now the final thing, we have the security group that is set up per our instances. We have lots of rules here, right? So this is the next rule. So we want to move the security group to the root level as well, where we will access port to port. So now I'll go ahead and put this security group over here because I want ports to be configured here on the higher level. Let's call it cluster and name. So we can have module VPC. Now that's interesting. So we want to allow TCP to any port. No, we do not do it anymore. Instead, we'll do it like this. So we allow NAT. So let's have here module VPC. So it means the only IP addresses within our network. And then we can have ports, local ports, nets, client. That's it. We don't need it for now. So this is how we set up the nets access. Now we need to set up the same for everything, for all the replicas of. So now I want to create the new variable of the way listed IP addresses. So I call it gmax addresses. And this one, the type of it will be list of strings, and default one, I'll set the default 0, 0. So this means the public access, but for now we don't care. And here I want to allow, oops, we don't need to have the, yes, we'll do it like this. Great. So here UDP, now we go TCP. Yeah, the frustration is that we need to create each of these statement for each port we have, and if we have like any services, this file will be huge, but I think we will figure out how to optimize this local object so it could be both accessed as an object, and also maybe we'll create an array from it, a list from it, and then iterate over the list and enable everything. We will think about it, but now I'll do it just everything in line. So here it will be health, this also will be health, and health is something we only allow internally, just red, on red, blue, just for. We also allow 22. Not sure if we need this one. I will need it for debug, so I'll keep it. So within VPC, and then egress we allow everywhere. So yes, this will be our security group, and we'll think about how to make it more concise, because right now we just explicitly specify which ports are accessible, which not. So we can control to which port we have access to. And from here, I'll create the variable. Hold on, I need to see how it's referenced. Security. No, not this one. Yes. So wait, only ID. Just cut it from here because it must be here. Yes. And wow, I just got an idea how we can optimize it. So instead of creating security group on the root level, we can leave this one here, and so we'll have it now. We'll need to have an object, something like rules. Let's make it a list of objects. Again, it's not super sexy, but I can't find anything more meaningful right now. List of objects, and each object will have port equals number, then protocol equals string, and then I think that's it. Let me check. Side blocks. Yes. So we good here. I just hear that I can do it like this. Default the protocol be TCP because all of services TCP except one. And so this one will be optional list with default one. Yep, like this. So it will keep our config really simple, and I love it. And then, so now I have dynamic statement, and we can have for protocol, and that's how we do it. So we can basically disable all of this crap, and yes, egress, everything good. So we don't need the root level security group as we did previously, but instead we'll handle it on the cluster level with just dynamic rules supplied. So now let's go to the cluster definition and say security group rules. Just create a couple of rules. So the first one will have a port at client, and we basically can keep it one line because it's really short one. Then the second one will be red traffic, and this one is UDP. Yeah, this one not gonna be the short one, so this one will be the more complicated one because we have the protocol UDP and we have the slider blocks. So this one will be just more complicated. Then let's have it here and then do the same for the blue. Now we need to have two more like these for health. And the health, they will just stay within VPC with TCP, so they don't need customs. I think this expression is much better than all of these crap. I'll remove this crap. Now it's much sexier. And we specifying the ports. I'm not sure if these stuff will actually work properly. We had something like that in here. So I think there were ports. No, here, ports. So container port is optional and we put it 0 as default. Yes, because usually they're the same and we have comparison and everything, so we'll be fine here. So now the problem is that we will probably not be able to deploy these Terraform in Terraform way because we make some significant changes to our infrastructure, changing a lot of network interfaces, everything, and these changes usually require a lot of resource to creation, so thus resources might be dependent on other resources and the Terraform apply will probably crash, but we can start doing it and then manually mitigate everything. Alright, so let's do the execution of the Terraform. So what I'm gonna do, I will run the Terraform apply here. Oh, I need to sign in. I've signed in. Now let's do the Terraform apply here. Oh, I see. Now we're getting the first error. Variables, that's obvious. We can use variables here. So what we're gonna do instead, let's go to ECS cluster. We put an empty one and then let's go to the place where we're actually defining. So here we'll do these. So if length of the cider blocks equals 0, then we put VPC cider, otherwise we put the cider blocks. That's it. Yes. So line 71 emoji max ingestor main. Yes. So it doesn't like the ports because they are different. So what we can do, we can simply, let me have a thought about it because I'm pretty sure there should be an out-of-the-box solution that will solve this. Let's open locals. Oh, I see. Looks like the problem was just I was passing ports instead of ports Gmax ingestor. Let's try it again. Looks like now works. So now let's observe because they want to actually add 5 resources and recreate 6, or I don't know. So let's go to the very up here and see what it will do. So it will update our ECS group with the rules we provided, and that's fair enough because this is what we wanted. So I don't have any concerns about it. So the listener will be updated. Yes, we will use port 9000 to the listener and 9001 here. That's totally fair. So the target group must be replaced. It might be the issue, but anyways, let's check what's going on here. So we can see that, yes, the port, which one it is. So the first one, I assume it's blue one. Yeah, it's a blue one. So the port has been changed because now we should have unique ports. That's totally expected. And the health check port is changed. Don't have anything else. This one though, I don't know what's happening with them because I have never set up these properties, and I think this is just because of the unidempotency of our deployment. So basically, sometimes when we defining the Terraform resource, it applies some default settings, and then for some reason they might have been changed on AWS. So the next time we apply, Terraform still try to apply the default ones, but as far as they have been changed on AWS, we see the changes over here. So to avoid things happening like that, we need to make sure that every time we configure something, and there are some properties that are subject to be dynamically changed, so we need to explicitly specify them. But this is not something we'll do right now. We'll do it later on. I'll leave it. It should not block us. Yes, so security group, we will destroy it because this security group was used for the ECS service under AWS VPC, but we gave up AWS VPC network mode for our ECS, so we destroyed the security group. The service of nets will be updated, and why? Because we make some changes to the task definition. Service registry, something has changed in service registry. I don't know, we'll see what is that. Task definition is totally fair. The nets task definition will be updated. That's totally fair because we'll use the static port. I don't know what are these. I think they just Terraform was not able to evaluate them, so we just specify them here or just in importance. We'll see. So the discovery service for what? For nets is changed because now we're using a recurring service SRV. That's totally fair. That's what we want. Let's see what else. Service for ingest RAD. We're removing the network configuration. It's no longer AWS VPC. That's totally expected, and task definition is updated. That's what we done. So now we have task definition for which service? For RAD. So now we have task definition for RAD. There are a couple of environment variables has been changed. We can see environment variables has been changed. The AWS mode has been changed. So this is what we expect. That's good. Now we have the blue service, ECS service. Yes, we updated the load balancer. And why? Because we have changed the port for the blue one. So red one didn't have load balancer update. The blue one will have because the port has been changed. So that's why. Network configuration has been dropped off because obviously we don't need it anymore here. Well, technically I'd love it to have here, but we can't have it with bridge mode. So the task definition for the blue one has been changed because a couple environment variables has been changed. Port, as well as the ports here, have been changed. That's great. So that's pretty much it. That the network has been changed. Everything is good. So again, I assume that this deployment will fail and we need to do some manual intervene it. But let's run it. It's not production deployment, it's we're just building, so we have a flexibility to crash everything, experiment, and it's better to do right now because if we go to the production, changes like this will be really painful and they will take a couple of weeks to deploy because they will cause downtimes and we need to create a strategy of how we avoid those downtimes. So that's another story. But so the security group is destroying and target group. So these guys will not destroy. Why? Because they assign to listeners. So Terraform will stuck in this flow for an hour. So I will not be waiting for them. I'll go to my browser and destroy them manually via UI. So I'm on my AWS console and I will go to the EC2. This is where load balancers are configured, and go to the load. So we have target groups, basically these two that we try to destroy. And if we click on them and click delete, we'll get an error. Yes, you see, because they are in use by listeners. So what we're gonna do instead, we go to load balancer. This is our load balancer that created by Terraform. These are the listeners. So I will delete these listeners. And this is tricky process. You should never do like that in the production deployment, anything like that. It's just because of the experimental nature of this project, we allow ourselves to do that. And now let's wait for them to be destroyed. Yes, we can see here that it still aims to destroy security group. I'm not sure about the target groups. I think they have been destroyed so far. Let me see. No, they still exist. No, they have been recreated. You can see new ports here. So they've been recreated. That's great. Now, security group stuck in destruction as well. I think the reason the same. So if you go to the VPC, these are the where security groups are stored. The security group is attached to the service. And yes, so this is the security group we're trying to destroy. If we click on that and click delete, we'll probably fail. We can't, because network interface is associated. So what we need to do, and Terraform couldn't unfortunately do it for us, when we're doing this Terraform stuff like that, we need to do it manually in a couple of steps. So first of all, we do and detach the security group, do one deployment, and then once it detached, we do the second one. But to speed things up, we have the flexibility. I'll do some manual interference here, which is not advisable, and ideally we should do it properly, but let's be bad guys today. So Elastic Container Service, the security group is attached to the services. These services have the security group attached, I'm pretty much sure. So if we go to, let me see, some configuration networking, I suppose, you can see the security group attached. So what I'm gonna do, I want to basically update the service, and I want to delete the security group here. Yes, I don't mind it. Let's see if it will. No, it doesn't allow us because what? Because target group. Yes, again, target group doesn't exist because it has been deleted and it still has old target group in the settings. This one, yes, let's simply remove it and just don't give a shit. We updated the blue one. Let's go to the red one and do the same. So what we're gonna do, we first of all detach the security group, bomb. Then we load balancer. Well, we need to remove this one as well, update, and let's check our logs. So the security group must be destroyed right now. Let's give it a couple of minutes, seconds, I think. It will destroy. It's still destroying. They still haven't realized that it will destroy now. So it is, let's check the ID. It's ID 36C1. Let me check if I have not mistaken when I was making assumption. This is that one security group. Where I was, sorry, I should go to VPC instead of this one. So this one should have security groups, and 36C1. This is the one tries to destroy. And I think it should be destroyable now. So let's Terraform still struggling to do so. Let me check what it has. Oh, it has still an associated. I know why that. Because probably ECS, when you're updating ECS service, it takes time for him to, in progress, you see the deployment is progress. It takes time for him to apply these changes. So we need to wait a couple of minutes until ECS will apply those changes. And then after they apply, the security group will be detached from this ECS. It will free up and they will be automatically destroyed by the Terraform. That's totally fair. We can just view what deployment says to us. It's in progress. So we started 3 minutes ago. That's fair enough. The last deployment happened 10 minutes. We hope this one will be faster. So the security group has been destroyed and we got a couple of crashes. Let's see what happened here. So deleting discovery service contain registered instances. Yes. So we want to delete the discovery service, the previous one, because we changed the S3 to a record. And I think the problem is that there are some tasks running attached to this service. So we might want to mitigate those tasks first. And load balancer listener doesn't want to be modified because it's not found. Obviously, we deleted it manually just to make security group delete. So we will, when we rerun the Terraform apply, it will be recreated. I'm not sure if we can do something with the service discovery manually. So let's give it one more try. Let's, maybe the security group will solve by himself. So now we have less changes to do. We can have a quick look up what's going on here. So listener will be created. That's great because we deleted it manually. Service will be updated. That's good. Discovery service must be replaced. So this guy failed last time. We'll see. This one is good. Service. Okay, cool. Load balance will be created because we deleted manually previous one. There's no security group here because we detached it manually. Task definition is fine. I think it's good. So let's do it. So discovery listeners has been created. Discovery service still fails. So let's go to the console and figure out what's going on. By the way, this should be done. It happened in 2 minutes, 53 seconds, really fast. Let's go to the discovery service. So we have the discovery namespace and cloud map, but I don't think it's a cloud map ready. Let's take a look. What do we have here? So we have here nets. Yes, so this is the one. Let me see. XP2R. This one. So this is the one it tries to delete and it can't. Why? Because we have this. If you register it, can we register? Let's check. Yeah, we just registered it. Cool. That was probably straightforward. Let's give it one more shot. I think the only change will be is the service discovery. Not the only, but a couple of them. But all of them are pretty much everything we done before. Oh, right. Now we have more errors. Let me see. Discovery service has been recreated. That's great. So task definition has been created. That's good. So service modification has failed. Oh, I see. So they don't like the A record for breach. Whoa, that creates lots of problem. So and I'm exhausted about it. The service registry has the A record because we want to point them to the specific port, but service doesn't like that. It says that we must use SRV. Wow, can we use both? Because the reason I was doing all that changing of the interfaces was because I want to use a record on breach mode. And if it doesn't work, that will really frustrate me. I'm curious if AWS has any documentation that says it explicitly rather than trial and error, because I spent lots of hours in it so far. Never mind. That was a really frustrating part. Yes, by the way, another thing, we forgot to change the target type in, how it's called, ECS service. Because using bridge modes, we want to use instance type versus IP. Let's go change it first because I know how to do it. So I think it's either done in load balancer. Here you go, instance. We need to change that, just this one. So this one should be solved, and I'm not sure what to do with the service. It really frustrates me. If I can't use the A record with the bridge or host, I'm super demotivated. Same story again. It can destroy target group. So we must go destroy listeners manually. So the target group destroyed and we have error. So I'll cancel this one. I'll go and actually there should be a workaround for that. Technically we can do the workaround, but I suppose it will not change it anymore. So which workaround can we do? So we basically can, in the target group, when we name it, we should add some random string. So every time it creates the instance as random string, and we create lifecycle policy to ignore the name. So if the name is changed, the Terraform will ignore it. And we create another policies create before destroy. So what does it mean? That the target group will be created attached to the listener or listener attached to it, and then only this one will be deleted. I don't want to do right now because I'm not really focused on changing target groups, having a production ready operation. I prefer that we never change target groups, and that's why we're doing all this right now. So when we go to the production, we will not need to do it. So I'll delete the listeners. So ideally, when we want to recreate target group, we also need to recreate the listeners, I suppose. And let's apply it again. So I think this stuff should work now. I'm not sure about this service. If it will not allow us to use A records on bridge, that it doesn't allow. So hopefully those are sorted, target groups are sorted. But now this one is super frustrated. I want to use A record. I don't care. I can't use AWS VPC. I would use it with love, but I can't because there you don't have these stupid limitations. But anyways, Kubernetes is a bit more expensive and it's just scary for most of the people. So when they're telling AWS ECS, they don't care. When telling Kubernetes, they're scared, but the complexity might be itself the same. The only problem is that, well, technically ECS brings you more managed solutions, so you need less stuff to manage and you rely more on AWS, and just brings you an illusion of safety, and the word ECS itself brings an illusion of simplicity, and you can easily get buy-in in using that technology. Well, if it comes with Fargate, it's just amazing. It's super simple in Kubernetes. Not super simple, but simple in Kubernetes. But if it comes with EC2, where you want to have cost optimization as well as the flexible deployment capabilities and robust, we are stuck here. So let me think what we can do here. Alright guys, I have a couple of news after doing a quick research. One is good, one is bad. I'll start with the bad one. The bad one is that we need to revert everything we've done so far and do it again. The good news, and the good one is really fucking good, that we will use AWS VPC mode. So I have found something I was unaware about. It's called Nitro. I don't know how to pronounce it properly. So basically, what it does, so this is the setting that allow us to provision ENI trunking for our container. So it means if we're using right now, we're using T4G, let me see. As far as I remember, the T4 are compatible. Let me see, they aren't listed here, but I have found something that T4 should be compatible. Yeah, so T4G is not in the list of unsupported, but it neither specified here. Why I'm using T4G because I use an ARM. I'll have another video about that. So basically, if we have medium instance, we can run 10 tasks per medium instance, which is, I think, sufficient, really. And it's not the limit of the tasks, actually. It's the limit of the tasks that are network compatible. So for instance, if they have some processing task that subscribe to the event queue and just pull the data and then put it to event queue, so they don't need IP address and they can exceed this limit. But this limit is only about the tasks that require to have network interface, IP address and port. And I think we'll have probably 60 or 70% of tasks that will require IP address. and also 30-40% of those it will require. So I think the limit of 10 is really fair here, because consider this is the medium one, and medium one has, I think, 2 CPUs and 4 gigs of RAM, something. That number, 10 tasks, will be really fair, and I don't think we need to deploy 10 in that much. So if we want to go with large, 5 large, also 10. If we go to one with 6 large, we have 20, and that's insane amount. And the X large too, it's 40. So I think this is a decent amount. So it means that now we can deploy the AWS VPC mode. Why I'm excited about AWS VPC? Because with AWS VPC, we assign the IP address to the container itself, or the task. Then we can have security group to the task, so we can more granular control of who can access these task, and what this task can access. And I really love it. I love to have as granular control as possible within our network, within our cluster. Yes, so I'm really excited about this news, and this video, it might be useless because, well, it might be useless from the result point of view because we didn't do anything. We didn't define the paradigm for deployment, but it's really useful from the point of view that we learned so far. So we learned how breach works, how host works, how APC works, and we learned all the limitations of them. So we'll be mostly there, and we will have this deployment. But I'm really glad that we failed, because now we know how to make it even better. I'm super excited. Let me show you the main concern about here. So what stopped us here? So basically, if we go to our ECS service, this is generic model used by all of the services. We have breach, that's fine. We've set up breach. The problematic point, where it is? I lost it. Yes, this one. So the breach mode, so we have the service discovery that assigns DNS. And the problem is that breach mode doesn't allow us to use A records here. It wants SRV, and SRV we need to client to manually resolve it. And it's a pain in the butt, and I hate it. I want the developers who develop applications to just don't care about how network works. They know that they can do it the usual way they're doing, just they make an TCP call to another service. They don't care how this TCP call goes. They don't care about how the DNS resolved. And I want to eat this complexity here, and this shit prevents us. Not this one, but a requirement of here being SRB prevents us, and I hate this. I'm really excited about the fact that we will use AWS VPC. So that's it for today. Thank you for watching. Stay tuned, because the next video will be basically on how we will deploy VPC with this Nitro enabled, and I'm really looking forward to it. So this one, we covered our attempt to do the breach deployment with the A record accessing. Anyway, stay tuned. If you're not subscribed, please subscribe and click the bell so you will be notified when we release the video about AWS VPC deployment. Thanks for watching, and I hope to see you on the next video. Cheers.